Hi, my name is Tyagi, and in this video, I'll be going over how high-speed trains work. So, to start, there are two main types of high-speed trains. There's maglev-based high-speed trains, and there's high-speed rail, or HSR for short. So before I get started diving into the physics and the engineering principles that govern these, incredible transit systems, I first want to talk about just some basic facts about them. So maglev is a technology that hasn't been implemented a lot. There's only about 50 miles of track in operation, and these are mostly test slash airport lines. And you have them in countries like China, Japan, South Korea, and they're not too long because again, there's only 50 miles globally that are operating today in the world. And maglev, these are really super ultra fast, trains, but they are very expensive. And we're still working out the issues and we're still conducting research with them, which is why they're super expensive. And also technology itself is super expensive right now. But in terms of max speed, the max speed ever recorded on a maglev train was by a Japanese train that reached a max speed of 375 miles per hour. And then the average is usually around somewhere from 150 to 190 miles per hour. Now with high-speed rail, we have much more widespread adoption. There's about 35,000 miles of high-speed rail, and this is concentrated in mainly Asia, so in countries like Japan, China, South Korea, Taiwan, these countries, and Europe. And for context, max speed ever achieved on one of these was by a French train, I believe, which reached 250 miles per hour. And the average is usually around 120 to about 150 miles per hour. So what makes maglev way faster than high-speed rail? Well, high-speed rail has to deal with two types of friction. It has air drag, right, and actual contact friction from the track, because high-speed rails actually runs with wheels on the track, so there's contact friction. Uh, friction. On the other hand, maglev, the only thing it has to deal with is air drag, because what maglev does is it actually levitates. That's the lev part, levitates using magnets, mag. So now let's dive into how these technologies really work on a more physical level. So with maglev, there are two types of maglev. There is, well, first we'll start with the cheaper and more, I guess, adopted, although neither maglev is really adopted. We have electromagnetic maglev suspension, or for short, um, I think it's EMS. So electromagnetic suspension maglev, how it works is if we imagine a maglev train like so, and then we imagine a track like this, right? So how it levitates is it uses the principle of magnets. And so the thing you need to know with magnets are that like poles repel and opposite poles, so like north and south or south and north, same thing. Opposite poles, they attract. Okay? So now if we imagine a maglev train that looks like this, a EMS maglev train, and if we zoom in to this point here, what we're going to see is we'll see the track. So this is the track. Has one magnet here, and meanwhile the train, which is going to look something like this probably. I'm not really drawing it, completely right, but right, there's a train, something like that. Right, so that's the kind of arm of the train going underneath. And so the magnets, there's one magnet on the track there. There's a magnet on the, sorry, not like this. There's a magnet here, and there's a magnet here on the side. So we can assume, let's just say this calls from north. These two are going to be south. And so what happens is that, sorry, this one would be the, yeah, this would be south, sorry. So these two attract, right? And so because they attract, the maglev becomes suspended here because they're attracting together. And so these magnets stopped. What would happen is this train would hit the tracks. But since these two are north and south, they attract each other, and the maglev remains elevated. So between the track and between here, the magnets, they have about a separation of 10 millimeters here, north and south. And then you have these magnets on the side too to prevent it from, going into the track on the side. And top to bottom, from the train to the track, you have a clearance of about 1.5 centimeters. So not a whole lot of clearance, but the important part of this type of maglev EMS is that you don't need any wheels. So it'll always remain levitating because of this attraction system. So electromagnetic levitation uses electromagnets to create a propulsion. So if we imagine the train here, how the propulsion works is, let's imagine the train has a north magnet here, a south magnet here, a south magnet here, north magnet here. And this is just a very simplified diagram. I just want to show you guys the principle of how a propulsion system works here. So now let's imagine the track has magnets south. Actually, no, call this one north. Actually, no, call it south. South, north. This one should be a little bigger, I guess. North and south. And then up here we'll have north, south, north. So what you can see from this diagram is that north, north, so these are going to repel. North, south, these are going to attract. South, south repels. South, north attracts. And same in the bottom, repel, attract, repel, attract. And so what happens is, because of the system, the cart wants to move because of the repel attract forces from the track. And so now, once the cart reaches this point here, right, you can see that the south and north are like right here. So it's going to be going, wants to go horizontally. And now you can imagine if we switch the polarity, so here, imagine north track, south track here. Imagine now if we switched it. Imagine this became south, this became north, this became south, this became north, and we switched all of the poles. What would happen is we would again reach a state where we'd have attraction, repulsion, and again we'd be moving forward. So the idea with maglev propulsion is that we have these tracks SN, 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 and we keep switching them to create propulsion. And that's how electromagnetic suspension or maglev works. In the electromagnetic part, what that means is that we use electromagnets, which are basically magnets that work because of a battery, and they work because we have them wrapped around a coil, and this coil creates a field, a magnetic field, concentrated around the center of the coil. And so if we have a ferromagnetic material at the center, what we'll get is a concentrated magnetic flux at the nail, or in this case, the magnets, and we get this magnetic field that allows levitation to occur. And next, there's also another type of magnetic levitation called electrodynamic suspension, and this is a more new and also theoretical type. We do have one in operation in Japan, and it's also way more faster than EMS maglevs. And so with electrodynamic suspension, or EDS, you have the same propulsion system, right, switching the south, north, but the difference is we use superconducting magnets. And superconducting magnets are better than electromagnets, and they can get the train faster with superconducting magnets versus electromagnetics, because superconducting magnets, I don't know why I'm saying magnetics, they have zero electric resistance. But they are harder to operate because you have to cool them to temperatures, really cold temperatures. So some of them have to be cooled down to about 450 degrees Celsius. And yeah, so they're really cold to operate. And once they're this cold, they can have a huge magnetic field and they're really strong. But again, it takes a lot of energy to cool them down to this much. So how they work is you have these trains, and the trains, they have these superconducted magnets inside. Then you have on the side of the tracks, here and here, you have these coils in figure 8 shapes, like so. So we have a south and a north, and these coils, levitation coils, when the superconducting magnet comes by it, they create eddy currents because the magnetic field from here is interacting with the coil on the tracks. And so this magnetic field, let's imagine this is a north magnet. What it does is it repels here and attracts there. And so what we get is we get levitation because of this, these eddy currents that cause a force to be applied on the train. And so in total, we're able to levitate using these superconducting magnets, these super strong magnets. We're able to levitate it to about 10 centimeters off the track, which if you think about it is way more than the EMS system, which is only about 1.5 centimeters. Because again, we're using superconducting magnets, so we're able to do it way more in a stronger fashion. And the principle of how they move is very similar again to, electromagnetic maglev trains. But the interesting part is just they use superconducting magnets to be faster. And finally, let's go over how high-speed rail works. So high-speed rail is a typical type of rail system. So they use wheels on a rail. But to make it actually faster than traditional rail, they have a couple of interesting things they do. So here is a toy train, but the important part to notice from this is the shape of the front. And so you can see the shape is kind of like a cone-like, futuristic-looking shape. And that's not for design. That's for actually a purpose. It's for aerodynamics. So if we're going at high speed on a rail, the issue we run into is air resistance, which tries to block our speed. And so by making the shape, we allow the air to more easily flow around the vehicle, which allows for higher speeds. High-speed rail also has less curves, slopes, and no on-level crossings. So no way having to cross with the road. It's all either elevated or there's bridges. Also, these trains are lighter, and they use, rather than diesel motors, which were the old system, or steam, which is really old, they use powerful electric motors. And these motors are way more powerful, and they're also lighter, which allows them to be faster and better than other trains. And also the tracks. So the tracks are welded, which allows for less bumps, and they have concrete connections between the tracks, which makes them again more stable. And finally, they also use active suspension. So while traditional trains might use springs for suspension of the wheels, high-speed rails use active suspension, consisting of sensors and actuators to create this suspension system that makes it way more smooth and faster. And yeah, those are how high-speed trains work, like maglev and high-speed rail. Thank you guys all for watching, and I hope this video was interesting to you all. Thank you and goodbye.